Right, so here's another question. So how are we gonna do this? So like 1 plus x to the power of n. I mean, this strategy is like gonna work for everything. So it's equal to nc0 plus nc1 into x plus nc2 into x squared and so on. So like ncn x power n, that's where this stops. And then maybe we can add, I think, an x to that thing. So it's like x into 1 plus x power n, that is going to be equal to nc0x plus nc1x squared plus nc2x cubed and so on. So like ncn x power n plus 1. And now you can just integrate these things, like it's the integral of x into 1 plus x power n dx, from I think x equals to 0. Yeah, that should work, from 0 to 1, right? That's going to be the same thing as when you integrate this thing. You basically get nc0 upon 2 into x squared plus nc, let's see, nc1 upon 3 into x cubed and so on. So like ncn upon n plus 2 x power n plus 2, and this goes from 0 to 1. So like when you put 1 in there, we just get this thing, this sum which we are looking for, and when you put 0, that thing vanishes. So now the question is, how do you integrate this thing? Well, I can write it as the integral of 1 plus x to the power of n plus 1 minus 1 plus x power n dx. Yeah, that should make sense. So like it's from 0 to 1. So let's integrate this thing. So it's going to be 1 plus x to the power of n plus 2 upon 2 minus 1, wait, upon n plus 2, sorry. 1 plus x to the power of n plus 1 upon n plus 1, and this goes from 0 to 1. All right. So let's put 1 over there. So you're gonna get 2 power n plus 2 upon n plus 2 minus 2 power n plus 1 upon n plus 1. And then when you put 0 over there, you get minus of 1 upon n plus 2, I think. Yeah, and then plus 1 upon n plus 1. Yeah, so let's see, what can we do with that? So what do we have to prove? Yeah, we have to prove that this is equal to that thing. So like, let's just take the LCM, right? So first of all, yeah, so like 2 power n plus 2 into n plus 2 power n plus 2 minus 2 power n plus 1 into n, and then minus, well, this 2 thing we can turn it into 2 power n. Yeah, that should make sense. Cool. Sorry, n plus 2 over there. Okay. And then this thing is upon n plus 1 into n plus 2. All right. And what about this thing? Okay, so it's going to be minus, well, let's see, it's like 1 upon n plus 1 minus of 1 upon n plus 2, which is going to be plus 1 upon n plus 1 into n plus 2. So like, just add 1 over there, plus 1. All right. So let's simplify this thing. So first of all, this can be cancelled with that thing. So it's going to be like 2 power n plus 1, and then you got 2n and minus 1, right? And what else have you got? You got that plus 1 over there, and this is like upon n plus 1 into n plus 2. Is that what we wanted? Well, no, maybe not. So it's like n plus 1 into n. That's different. Hey, maybe it was a negative. Oh yeah, sure. So like it was, wait, what? That doesn't make sense. Yes, it's like 2n plus 2. Wait, something is definitely wrong. I don't know, but something is like seemingly wrong over there. So it's supposed to be 2 power n plus 2 minus 2 power n plus 1 stuff. Yeah, that's correct. That's like really correct. Okay. So then it's supposed to be 2n plus 2 minus of, yeah, I mean it should have be having the n over there. So why did this not work? Alright, so 2 power n plus 1 into n. Yeah, there's this problem. It's supposed to be n over there, not 1, not minus 1. Yeah, sorry for that. So it's supposed to be 2 power n plus 1 into n plus 1 upon n plus 1 into n plus 2, which is exactly what we wanted. So yeah, that's it. So this question is done. I will see you in the next one.